Hello, welcome back, everyone, to Adventures in the Library. We're going to continue on in our exploration. I believe we were working on in the nucleotides. We had discussed that we are going to be, anytime we're talking about psychology and psychological disorders, we're going to talk about the disease of the psyche. We're going to continuously use, rather than using the human, we're talking about the mind. Anything we're talking, that we're going to differentiate the brain from the mind by using the term psyche for the mind and anything related to psychology, and we're going to use the brain for anything regarding the physical and the medical and chemical side of our existence. So the psyche will be the intangible parts. The tangible parts will be relegated to the brain. That's the way we're going to set up our construct there. And then we'll move on in there. So let's get back into the encyclopedia and move forward. Okay. We are at the point we want to get into, and because we saw here that we see in the book here that it says see carbohydrates for the pentose, right? And my suspicion is, and this is what will confirm it, that because I do know where that this is leading. This is leading to organic chemistry, but we want to confirm it in here. We don't want to simply leave our suspicions. We want to confirm them, right? And we want to let the book itself tell us where we need to go. So I'm going to leave this here for now, and we're going to leave nucleotides, and we're going to go over to carbohydrates. Okay, we're getting close. Okay. We got C-O, C-O-M, color, clutch, we're getting closer. Close there. Crystal, character, C-A, here we go, car. Carbo, there we go. Carbonic. We're in the area there of carbon now, so we should be getting here. Yeah, here we go. Carbohydrates. And there is a huge section on carbohydrates. It's not a small thing, carbohydrates. So there's a lot of information. Same thing with the nucleotides. So we're going to be in nucleotides and carbohydrates for a fair bit of time due to the actual size of it. So here we go, carbohydrates. And I'm going to get up my bag up of bookmarks. This time it's a jack of clubs, and we'll put it in here. And we'll start reading. Carbohydrates. Carbohydrates are a hydroxy are polyhydroxy aldehydes or ketones, or the products which are chemically related to such simple units by the combination of two or more units through the loss of water. Higher units are thus aldehydes and yield simple units referred to above by the treatment with acids such as hydrochloric acid or as hydrochloric or sulfuric or particular enzymes. Carbohydrates respond to the alpha naphthol test. The alpha naphthol test as given under glucose reaction number 12. And there's a reference below. I have to take a look at there. When heated in air, carbohydrates burn to form carbon dioxide plus water, evolving heat. 2. In the absence of air, combustible gases, watery and tarry distillates, and charcoal residue. Carbohydrates may be classified as follows: monosaccharides, sugars, right? Crystalline solids, soluble in water, sweet taste. Those that occur in nature are hydrolyzed by certain enzymes, and they give a huge number. Well, a fair number of this type of monosaccharide. And from what I'm seeing, most of the sugars end in the OSE thing. This is what they've gotten here. Now, as I say, because I know this leads into organic chemistry, even though they haven't said this leads into organic chemistry, what I will do is, because I have this understanding of organic chemistry, I will go check to see what it says under organic chemistry. Now, the one I think we're looking at is number 4, ribose, because we know ribose from ribonucleic acid. So what we can see here is that that ribonucleic acid is probably a carbohydrate reaction that moves a sugar with water into an acid. Because I know you can go, if you do a distillation of sugar in water, you can produce alcohol, which is also an organic acid. So therefore, it is not too much of a stretch to say that you can go from a sugar to another organic acid, such as ribonucleic acid. So sugar and carbohydrates play a central role in RNA and DNA and nucleotides. So this is where we can. This is sort of, and this is kind of how we got here. We were looking at nucleotides, and they say C carbohydrates right off the bat. They were saying C carbohydrates. So now we see right here that RNA and DNA is directly connected to sugar. And what I'm talking about here is these sugars here. And now all these things are more or less called sugars. And well, there seems to be two categories of sugar here we're looking at. Sugars are either monosaccharides or disaccharides. Once you get into trisaccharides and polysaccharides, you're not in the sugars anymore. But what happens is that you have basically a polysaccharide would be a chain of monosaccharides. And that's actually what they show here. They show the monosaccharides lined up together in a bond, forming a polysaccharide. And if you know the Greek, poly means many. So you go from the mono, which means one saccharide, to the polysaccharide. This tells you that a polysaccharide is many monosaccharides, and that's what poly means. Poly means many. When we look at the polysaccharides, we see starches, cellulose, dextrin. Insulin is a polysaccharide. Glycogen, and so these are the ones. These are the ones we sort of know. Cellulose is what we see in plants. Cellulose is particular to plants. These are the plant starches. If you're a vegetarian, you eat you eat a lot of vegetables. It's the celluloses that are in the plant. That's what you're digesting. We're also when we're having bread or anything with wheat in it, any things that have seeds, we're dealing with the starches. This is true for popcorn. This is true for cornstarch. This is, but when we go back to monosaccharides and talk about the sugars, well, the sugars are within the carbohydrates. They're in the carbohydrate, but there are sections of the carbohydrates groups to a certain degree where you can say all of the carbohydrates are in some form or another sugars, although the polysaccharides, which are in this book here, classified not as sugars, non-sugars, what they are is many sugars linked together. So they are fundamentally a sugar, and in many cases, when you do hydrolyze these, when you break them down, what you do get out of here is you get a number of sugars out of it. The monosaccharides. And here's some of the ones. The one that commonly seems to be across all of these different, or I say a majority of these different starches. The one that it breaks down to is yields glucose. Yields glucose. Yields glucose. And if we go to the monosaccharides and we look to see if glucose is on the list, and there it is, glucose. Glucose is on the list of the monosaccharides, and it's known as a hexoses. And so what we want to see here is we're looking. They don't have fructose in here for some reason. So we know the part of sugar. There's two parts of the sugar that we have. It's fructose and glucose. You may have heard of fructose because you hear of high fructose corn syrup. That's commonly used in soft drinks. So this is where we are now. We've gone from we were in nucleotides and nucleic acids. It told us to go see carbohydrates. We went and saw carbohydrates. This brought us to sugars and monosaccharides. Monosaccharides led us to polysaccharides, and and we see that in many cases when we're dealing with a monosaccharide like ribose or glucose or fructose, the OSE at the end indicates that you're dealing with a monosaccharide. Anyways, our 15 minutes is up. I will see you in the next segment.